In the last videos of the structure of atom, we already discussed the Bohr Rutherford's atomic model. The main postulates are atom is spherical in shape and mostly hollow. At the center of every atom, there is a dense charged particles. That is, positive charged particles is called nucleus. Electrons revolve around the nucleus like planets revolve around the sun. Okay, but some of the greatest drawback is also there. That drawback is nothing but when a charged particle is revolving around the nucleus, it should lose the energy continuously, and because of the attraction between the electron and as well as the nucleus, it will take a spiral path and eventually it should fall inside the nucleus. But it is not at all happening. Means the energy of the electron is constant, energy of the particle is also constant. Why? What is the reason for this? The reason for that constant energy was explained by quantum theory of radiation. This quantum theory of radiation proposed by Max Planck. Max Planck studied black body radiation. Means he studied the properties of the black body radiation. What is a black body? The body which is present in the space. Of course, it is not a body, it is an area in space. In space, in a particular area, large amount of energy is gathered. Means it will absorb enormous amount of energy and it will emit enormous amount of energy. So, in a particular space, where more amount of the energy is there, that is called black body. For example, if you consider a black body is here, this black body contain, this means the black body emits enormous amount of energy in all the directions. This enormous amount of energy will be there in the form of electromagnetic waves. Enormous amount of energy that is there in the form of from a black body emits in all the directions in the form of an electromagnetic wave. This electromagnetic wave must and should associated with some amount of energy, some wavelength, frequency, and as well as time period. These are all the four factors that we can determine an electromagnetic wave. The enormous amount of energy that present in the universe will travel from one place to another place in the form of electromagnetic wave associated with some amount of energy, wavelength, frequency, time period. Energy represented by E, wavelength lambda, frequency nu, time period it is T. Okay, this energy what it is traveling in the form of electromagnetic waves, that energy is directly proportional to its frequency. Energy of an electromagnetic wave is directly proportional to its frequency. To remove the proportionality, we should introduce a constant, that constant K and as well as nu. This constant K is called Planck constant, represented by letter H. Now, by removing K, we can write H nu. Now, E is equal to H nu is the packet of energy which is given by Max Planck. The enormous amount of energy is there in the form of packet. That packet is nothing but H nu. This H nu is called quanta. Now, one quanta is equal to 1 H nu. Now, 2 quantas of is equal to 2 H nu. 3 quantas is equal to 3 H nu. This can be summarized like this. E is equal to m H nu, where H is called as Planck's constant, The value of Planck's constant is 6.626 into 10 power minus 27 erg into second, or h is equal to 6.626 into 10 power minus 34 joule into second. What does this mean? The energy that is there along with the electromagnetic wave is in the form of a packet of energy, means it is not in a continuous manner, it is in a discrete values. What is the meaning of discrete value? Particular quantity of energy is called as a discrete value. If it is continuously flowing, then that is called continuous. See the statement now. Electromagnetic energy can be gained or lost in the discrete values, means in a perfect quantity values only, not in the form of a continuous manner. Then what happens? The enormous amount of energy that is coming from the universe in the form of packets falls on all the bodies. Then all the bodies absorb that enormous amount of energy and store the energy in the form of packet. That packet of energy we are calling as quanta. So the quanta is a packet of energy that falls on all the objects. Object means molecules, means atoms, means subatomic particles like electrons, protons and neutrons. So like that, every subatomic particle like electrons, protons and neutrons gains energy from the space and store the energy in the form of a packet. Either it may be 1h nu or 2h nu, 3h nu or nh nu. The statement is packets of energy of an electromagnetic wave is in the integral multiple of h nu, that is 1h nu, 2h nu, 3h nu. Let us learn one more atomic model, that is Bohr atomic model, which was proposed by Niels Bohr. What is the need of Niels Bohr atomic model? Niels Bohr tried to rectify the defects of Rutherford's atomic model, that is stability of atom, mainly the stability of atom. For that purpose, what he did, he adopted some of the basic properties of Rutherford's atomic model, like atom is space, means atom is largely in space. Okay, at the center of atom nucleus is there. Electrons are revolving around the nucleus in a circular path. That the word is given by Rutherford. But what the Niels Bohr will says, at the center of every atom nucleus is there, and the electrons are revolve around the nucleus in definite circular paths, means more number of paths are there to revolve around the nucleus. What he is saying, electrons revolve around the nucleus in a definite circular paths. This is nothing but the nucleus, where this is center is called nucleus, where here protons and at the same time neutrons are present. For that sake only protons and neutrons are called nucleons. Then this total center is considered as nucleus. Here electrons are revolve around the nucleus in definite circular paths. These circular paths are called orbits or shell. The particular path chosen by the electron to revolve around the nucleus is called orbit or shell. These orbits or shells represented by letter n, where here n is equal to 1 is also called K shell, n is equal to 2, that is L shell, n is equal to 3, that is M shell, n is equal to 4, that is N shell. Electrons revolve around the nucleus in a definite circular paths. Those paths are called orbits or shells. These orbits or shells are represented by letters small m. N is equal to 1 K shell, N is equal to 2 L shell, N is equal to 3 M shell, N is equal to 4 N shell. For example, if we consider an electron is there in the first level, it contains one packet of energy, means it will store one packet of energy. If an electron is there in the second level, it contains two packets of energy. If the electron is there in the third level, it contains 4 packets of energy. If the electron is there in the fourth level, it contains 4 packets of energy. What does it mean? As the size increases, energy of the path also increases. As the size decreases, energy of the path also decreases. As per this explanation, we can say that N is equal to 1, which is very close to the nucleus, having less amount of energy. Okay, here as per the Max Planck, enormous amount of energy that is there in the form of packet falls on the electron. That electron will absorb that amount of energy. Here if you consider second level and as well as third level, an electron is there in the second level and that is nothing but L level, and an electron is there in the third level, that is nothing but M level. Now this second level is called lower energy level. Lower energy level are also called ground level. If the electron is there in the third level, that level is called higher energy level, are also called excited state. If an electron wants to jump from ground level to higher energy level, that is from lower energy level to higher energy level, what it should do? It will gain some amount of energy in the form of packet. Already it contains 2 packets of energy. By gaining one more quantum of energy, the electron bounces into the higher energy level. If an electron which is there in the lower energy level gains energy and is jump into the higher energy level, if the electron is there in the higher energy level with 3 quantas of energy, and if it is want to jump to the lower energy level, that is 2 quantas of energy, what should it happen? It may lose 1 quanta of energy. 3 quantas minus 2 quantas, 1 quanta of energy. Lower level to higher level gains the energy. Higher level to lower level loses energy. Either loss of energy or gain of energy can be represented as here E2 minus E1 is equal to plus NH nu. Here E2 minus E1 is equal to minus NH nu. Either gain of energy or loss of energy always will be in the discrete packets of energy only. It is not at all in continuous manner. If it will be there either 1 quanta or 2 quantas or 3 quantas or 4 quantas, it should not be 1.5 quanta, 3.7 quantas, fractions should not be existed. Only numerical values clearly will be existed. Of course, if the electron is there only in the second level, or if the electron is there in the third level, that means electron is not jumped from lower level to higher level or from higher level to lower level, it neither lose energy nor gain energy. That means energy of the electron is always constant. Then automatically energy of the orbit is also constant. Such orbits are called stationary orbits. Now what are the final conclusions? Electrons revolve around the nucleus in definite circular paths. Those paths are called N is equal to 1 K shell, n is equal to 2 L shell, n is equal to 3 M shell, n is equal to 4 N shell. As the size increases, the energy also increases. As per that, the shell which is very close to the nucleus has less amount of energy, that is K shell. If the electron try to jump from lower level to higher level, it gains energy in the form of radiation. If an electron want to jump from higher level to lower level, it loses energy in the form of radiation. As long as electron is revolving in the same nucleus, it neither lose energy nor gain energy. So the energy of the electron is constant, automatically energy of the shell is also constant. For that sake only those shells are called stationary shells or stationary orbits. As we already know, every atomic model has some shortcomings, that is some drawbacks. Even Niels Bohr atomic model, which is a very structured manner when compared to Rutherford model, then it also has some drawbacks. Now, what are those drawbacks? The first drawback is he is unable to explain the Zeeman effect and Stark effect. In the next videos, we are going to learn what is Zeeman effect and Stark effects. The next failure is he failed to explain the formation of chemical bonds. Why hydrogen atom combined with another hydrogen? Why hydrogen is combining with the chlorine? Sometimes 3 atoms of hydrogen is combining with 1 atom of nitrogen. Same hydrogen, 2 atoms of hydrogen is combining with 1 atom of oxygen. Like that, single atom, why it is behaving in different manner, he failed to explain. Why? Because that is also a part of structure of atom. In the third case, he explained the spectra of hydrogen atom. Only spectra of hydrogen atom. Why? Because hydrogen atom contains only 1 electron. That means totally the Bohr atomic model, which is very successful, able to explain the spectra of atoms which have only 1 electron. But in the nature, different kinds of elements with different kinds of electrons are there. Helium has 2 electrons, lithium has 3 electrons, like that. Innumerable number of atoms have different kinds of electrons. He failed to explain the spectra of atoms with multi-electrons. These are all the drawbacks or otherwise shortcomings of Rutherford's atomic model. But whatever it may be, because of the introduction of multi-electron systems and by the application of Max Planck quantum theory of radiation to the structure of atom, he introduced a new type of system in the structure of atom. Because of that development, a new branch of structure of atom was introduced. That is nothing but quantum mechanical model of atoms. This quantum mechanical model of atoms, which was explained in later by applying Zeeman effect and Stark effect along with the Heisenberg uncertainty principle, by applying Schrodinger's wave equation. Thank you.